everyone, and welcome to this Telit Cinterion and CalAmp webinar, How to Protect Assets with IoT-Enabled Telematics. I'm Amanda Flink, the head of global events here at Telit, and I will be moderating today's event. Now let's get to know our speakers. To explain this topic today, I am pleased to be joined by two speakers. First, we have Marco Stracuzzi, the head of product marketing at Telit Cinterion. Second, we have Todd Ague, the senior director of edge device product management at CalAmp. Now, just before I hand it over to Marco to start our presentation, I do have a few quick reminders. I would like to remind our audience that we will have time to answer some questions at the end of our presentation. You can simply submit a question by posting in the questions box, which is located near the bottom of your screen. Also, please be sure to check out the resources section for some additional information on today's topic. We've got a few blogs and other things from both Telit Cinterion and CalAmp there for you. And finally, we will send out the replay link to all attendees at the conclusion of our webinar today. And with that, Marco, I will hand it over to you to start our presentation.
Thanks, Amanda. Hi, everyone. Glad to be here. Maybe before I'll dive into today's focus topic, I'll start with just a quick word on Telit Cinterion, for those of you who may not be familiar with our company yet. So as the name itself suggests, since the beginning of this year, we're bringing together two of the historic leading cellular module vendors in the market, Telit and Cinterion, former Telit IoT, and even before that, Gemalto. So now we are a single joint company, Telit Cinterion, and we are an enabler of IoT solutions. Our mission is to make IoT simple and secure for our customers. And this is thanks to wireless communication modems, cellular connectivity solutions, and cloud platforms for device management and data delivery. We serve multiple different industry verticals, and among the others, one of the biggest is telematics and tracking, which is about every vehicle and more in general, every asset that needs to be securely connected, monitored, and tracked. So, few more data points about the telematics and tracking segment in this slide, and this is coming from the market research firm Berg Insight. Berg Insight make many reports about the different applications in the telematics and tracking market, and among the others, they analyze fleet management, container tracking, including, for example, refrigerated containers for cold chain monitoring. Then trailer tracking, telematics for passenger cars, trucks, commercial vehicles, and car rental and leasing, as well as, for example, off-highway, heavy construction equipment telematics like tractors, diggers, etc. So what Berg call aftermarket car telematics solutions include both cellular, GNSS, and RF-based solutions. And aftermarket car telematics solutions are useful in a number of application areas, including stolen vehicle tracking and recovery, vehicle diagnostic, fleet management, Wi-Fi hotspot, convenience applications, and user-based insurance, just to name a few. So as you can see also from the graph in the slide, the uptake of telematics in the industry is believed to be driven by requirements for fleet managers to increase fleet utilization, the emergence of new mobility services, and also, in general, the electrification trend in the automotive industry. Now, fleet managers have an obvious interest in tracking the location of their vehicles and monitoring their status in order to prevent fraud, theft, and mistreatment in the long run. And this leads to reduced operational costs and also potentially lower insurance premiums. It's also very important for fleet managers to gather and process vehicle data to offer new services to their end customer. Lastly, it's worthwhile mentioning that the COVID-19 pandemic has moreover pushed the demand for digital business models, increasing the uptake of telematics in both the rental and leasing industries. Um, Now, CalAmp, which we are honored to host for this webinar today, and thank you, Todd, for being here with us, is ranked by Berg among the top 5 leading vendor in the aftermarket telematics hardware segment. Now, before continuing and diving into what is special about CalAmp telematics solutions powered by Telit Cinterion technology, let's take a look at the typical telematics or asset tracking infrastructure, which is made of 4 main segments. The first one is the vehicle segment, which is where our customers, the CalAmps of this world, offer their devices to communicate with multiple peripherals of the vehicle to get the data out of it and then connect it to the network to transmit the data. Then we have the network segment, usually the cellular network. It gives the wireless connectivity to the vehicle or to the asset that must be tracked and monitored. GNSS segment. GNSS segment is about using satellite-based location technology to track the position of the vehicle or of the asset as it moves around. And finally, what Berg calls the back office or service segment, which is again where our customers offer their application to do business analytics of the data they collect from the field and deliver business relevant information to the end user. At Telit Cinterion, we enable our customers' solution in each of these segments, providing them with the key ingredients to architect their complete telematics solution. So, for example, for the network segment, we have an extensive offering of cellular modules to be integrated in the edge devices to get them connected to the cellular network. Many times, telematics OBD dongle manufacturers are looking for more and more hardware miniaturization, and we can support them with some of the smallest modules in the market. We also offer cellular connectivity solutions through our own IoT MVNO global SIM cards, and wide global roamer coverage at reasonable tariffs is a must for telematics service providers. And we offer global coverage within a single SIM that can be available in multiple physical form factors, can be a traditional plastic card or soldered down embedded SIM or an integrated SIM inside the module itself. We also provide smart connectivity activation tools that can be used by our customers to provision the cellular subscription at manufacturing or directly in the field. So this was the network segment. For the GNSS segment, we have standalone GNSS modules for positioning and tracking. Customers, like fleet managers, most of the times are looking for solutions which ensure continuous tracking. And to satisfy this requirement, we have both standalone and embedded GNSS solutions that can work concurrently with the LTE, the cellular connection, ensuring continuous tracking without any interruption. Then finally, with regards to the back office service segment, so here we help enable the customer's applications with our device to cloud solution. It's called One Edge. In fact, big fleet deployments raise the need for remote management tools, for centralized, efficient photo campaigns and device management tools. One Edge includes a photo service to make sure our customers can update their devices in the field to fix issues or to enable new features, to roll out new features. Device management to have a real-time monitoring tool to control the installed base of devices. And optionally, we can also take care of the orchestration of their data from the edge device to the cloud and vice versa using Lightweight M2M, which, as the name itself suggests, is a very thin protocol that is optimized for constrained devices sending data over to the cellular network. Now that we have a clear view of the overall infrastructure of a telematics and tracking system, let's see what are some of the main subsegments and use cases where IoT-enabled telematics solutions can help connect and protect vehicle and assets. Let's start from school transportation service, which is a typical example of an intelligent transportation system in a smart city environment. Other similar examples are connected buses, coaches, trams, trains. Then next one, please let me go counterclockwise in the circle here in the slide. So vehicle telemetry to monitor key parameters of the car, like oil level, fuel level, or battery level, and this allows for predictive maintenance. Then we have fleet management solutions, including driver behavior monitoring, stolen vehicle tracking and recovery systems, and this is all to give more control to the fleet managers over their fleets, but also to give them the ability to offer advanced services like usage-based rental and leasing or pay-as-you-drive insurance. Then we also have connected heavy equipment, diggers, tractors for construction as well as for smart agriculture. And then I would say everything that does not have wheels, but is an important asset to track remotely. Can be a container or even a single pallet or package that is shipped around the world and needs to be located and monitored from the time it is shipped until it is delivered. And I think with that said, I will now hand it over to Todd, who will tell you about the amazing things that CalAmp devices and services can do for each of these use cases I've just talked about. So Todd, all yours.
Thank you very much, Marco. And really an excellent backdrop to going from exactly what Telit Cinterion is focusing on in terms of the markets addressed and the capabilities and how it works in our world, where, as you can see in the diagram, the device in the lower left corner is really pretty critical in gathering all data in a way that works with our operating system and our hosted applications, which are all internally developed here and are really optimized to meet a number of the different use cases that you've covered to serve this really the same set of verticals that you also covered, and across a wide variety of our overall devices. What's key here is that this system, the way that the device works with the firmware and then ultimately over to our CalAmp Telematics Cloud platform, that's the more of that data that we can process on the edge at the device level, the more efficient our platform can be to ultimately get either via API feed to our clients or our embedded services on top of the platform or out to the application that we have that allows clients to actually interact with the data. No matter how they're using the data, the more efficiently we can process it, the more we can really optimize our own efficiency and pass that efficiency along to clients. So this diagram is really just to show how device with, of course, a core module within that device works throughout our entire ecosystem to deliver the full stack solution to clients. And looking at that, we can kind of see, starting at the device level, all the different device types we have. And what's important here is to really understand that the family of devices that you see here is designed to meet specific use cases against specific verticals. So as we start really over in the far left, commercial and passenger vehicles, there's a need for basic OBD devices and more advanced OBD devices that can do driver diagnostics and engine diagnostics, driver behavior monitoring, across the gamut to a hardwired version of that, and then ultimately to even more sophisticated gateway versions that have more input-output capability and even more processing power to cover lots more sensors that could be hooked up to those. That's not only in the advanced fleet tracking case, but as you move over more into construction and OEM, the devices tend to be, yes, the more advanced gateways and processing power, maybe a few less input and output configurations, but definitely more ruggedized and more waterproof, water resistant. And so we we basically use the same variation of a gateway device, an advanced gateway device, for our general fleet tracking over in the OEM space, and that allows us to leverage how we build the devices in a more efficient way, cover more of the market with just variations on devices instead of purpose-built individual devices across all these categories. And then as you go further over into the smart trailer and supply chain categories, things get even more extensive, especially in terms of the number of sensors that can hook up to these gateway devices and how those sensors can work to monitor anything from wheel end temperature sense to pressure in the tires, to brake temperature, door open and close status, whether a light is out or not, or even integrating, say, a cargo volumetric camera within the trailer to see how full the trailer is. All of that is designed to basically protect anything going on both inside the trailer and outside the trailer. And then back in the commercial and passenger vehicle fleet tracking cases, that's more what's going on in the driver area. So lots of different ways to monitor the condition of the trailer, of the cab, of the cargo within it. And then on the further right end, for higher value assets, sometimes it's an asset itself. Think of a real expensive generator in a field that might not need to report as frequently, but still needs to report its location each day. There can be other sensors on some of those high value assets too that can communicate through our gateways. So in looking at all that, and really an area of focus is on the next slide, which is really just a variation of the first one, but you can see the box that calls out some of these really important gateways, the ones that have the most processing power, the most connections, and really the most capabilities. And those are our LMU and HMU variants. H is more for heavy duty, and the LMU that you see here, the 4350 in orange, that's utilizing the new EdgeCore platform and application. That's really a new flagship device we're building in both general fleet tracking and heavy duty configurations. So this is really technology we're developing now that will extend out and will leverage both the firmware component of that as well as the device itself to cover the product line more broadly as we continue to develop against our roadmap. And what's key here is how we've built this device. It is designed to be global, so it's global Cat 1, and as we looked at the need to go to global Cat 1 to not have a bunch of regional variants and modules, the Telit Cinterion LE91 or 910C1 is the key component here. It replaced an older Cat 1 module we were using in other applications. It is global, and it's future-proof 5G. All of these things were at the top of our list as to selecting the right module component for this overall device. And the idea here is that this will cover and handle the processing capabilities needed for EdgeCore and EdgeApp. It will also have extensive input and output capabilities, so lots of digital ins and outs. All of these inputs and outputs represent a sensor that could be hooked up or some other monitoring apparatus that we would care about that would all put, would start to tax the module that's in it. So processing power is really critical for this device. And, the other thing that was important is the form factor of the device. The size still needs to be compact, needs to be very efficient in layout. So when you look at the module that needs to serve the need here, in addition to being very powerful and global and Cat 1, it also needs to fit into a fairly small form factor because that's something that certainly our clients demand. They want the install experience to be a good one, an easy one, and they need to be able to ensure that the mounted device is safe and secure. The smaller it is, the better off we are there. So that's an overview going from our overall device portfolio right down to a use case of working directly with Telit Cinterion. And really with that, Marco, I can hand it back to you to cover maybe some more of the capabilities that you have in terms of solution architecture.
Thanks, Todd. This was really great overview, and it actually helps me to introduce the next slide because you somehow mentioned it already. So Telit Cinterion modules are not simply bit pipe cellular modems that are just used to transmit and receive data with the network. They do much more. They are robust, reliable, feature-rich, intelligent modules because they come with value-added software that allows customers like CalAmp to run their own application code on the processor of the module itself. We call the application development environment inside our modules IoT App Zone. Its main purpose is to allow customers to build their application and run their embedded software on the module without the need for an external MCU. So optimizing the electronic bill of material of the overall device. In the specific case of CalAmp, IoT App Zone is the application development framework with dedicated memory resources and processing power that allows CalAmp to offer their enhanced edge intelligence services. So the edge core operating system that Todd talked about, and with also the edge app hosted applications for the end customer. The IoT App Zone software package that comes with our modules includes an Eclipse-based IDE, common APIs for greater portability across multiple Telit Cinterion module families. So Todd mentioned they transitioned from an older part to the new LE910 C1, and they may take another leap to 5G in few years from now. So what we try to make possible is a smooth transition across different generation of Telit Cinterion modules, keeping the same software APIs, the same software interfaces, so enabling portability also of the customer application with zero or at least reduced development effort when they move from a product to a next generation. Then also the App Zone package includes diagnostic tools, libraries, extensions. I didn't mention it's based on standard C code, and also we provide as part of the application development package also getting started guide, developer guides, reference documentation, sample apps, and also a technical support spread across all regions is available to really help our customers and make it very simple for them to leverage IoT App Zone for their own application development. Now, I'm switching gears a bit here. At the beginning of today's presentation, we looked at the overall infrastructure of a telematics system. Then we focused so far on the edge device segment, talking about CalAmp products and Telit Cinterion modules inside those products. But to connect an IoT-enabled telematics solution, you also need a global SIM card to be placed next to the module, just as you need a SIM to make your smartphone connect to the network. And for IoT projects is even more important to include connectivity from the early stages of application design, so from the very inception of the application and then along the whole life cycle. And at Telit Cinterion, we are an IoT MVNO, so we offer global coverage to telematics service providers through our multi-IMSI and EUICC SIMs. And also we offer technical support across all different time zones in the world. So let me mention what are the unique advantages of our cellular connectivity offering. So we talked about global coverage. So Todd mentioned they are using LTE Cat1 because that's a technology globally supported by the networks. but again, one thing you need is the communication module, but then you need global coverage also when you consider the SIM card and the cellular data plan. And we can offer this thanks to extensive agreements we have with multiple mobile network operators in the different regions. Then simplified intelligent billing. So first of all, our customers will receive a single bill from us wherever their fleets are deployed in the world. And then our network has an automated engine that is able to offer the best rates wherever the vehicle goes. And this is by automatically optimizing the rates for cost efficiency. Then security is paramount, so our customers can work confidently while our enterprise-grade security keeps their development safe. And we offer all-in-one hardware and connectivity solutions. So we own both the communication modem and the SIM, so we can bundle connectivity services with cellular modules for enhanced capabilities and ease of use. And last but not least, reliability. So our customers can operate across the globe knowing that our virtualized cloud core network is fully geo-redundant on premises and also via AWS cloud. So when we talk about cellular connectivity, it's important to mention that it's not enough to have a cellular data subscription in the device. But it is also key to get the right remote management tools to locate your fleet of SIMs in the field, to control the traffic they generate and get alerts in case of abnormal data consumption. Even you can set up some logics so that when a certain traffic threshold is crossed, you want to automatically stop that SIM card from exchanging more data with the network, so you avoid any bill shock. Also, it's important to have the tools to diagnose any connectivity problem there may be, so understand if something is going wrong with a specific network and maybe switch to a different network operator that is also available in that location. And so ultimately, it's important to have the tools to manage the fleet of SIM cards at any time, just like you want to manage also the fleet of the devices. This is why when we talk with our customers about connectivity, we don't talk about connectivity only. We always talk about managed connectivity and connectivity management tools. Okay, so I have already been talking for too long, but I hope together with Todd, we managed to give you a sense on how Telit Cinterion, together with our partner CalAmp, can help in enabling IoT solutions for a variety of telematics use cases. And I'm now handing it back to you, Amanda, for the Q&A session, I guess.
Yes, thank you so much, Marco and Todd. Now, audience, before we get to the questions, I am going to drop a poll on your screen here. If you'd like to have one of our experts contact you, if you have any questions that you'd like to go over one-on-one, please just respond here on the poll and we will be sure to connect somebody with you after the webinar here. As Marco mentioned, we do have time for a few questions and there is still time to ask a question. So please just feel free to submit using the box on your screen and we will do our best to cover it in the short time that we've got left here. We've gotten a couple, so I'll just go ahead and dive right in here. First question, is an MCU always required to make a tracking solution?
Maybe I can start off with this one. So let's say, yes, you need an MCU, but what the point I want to make here is an MCU is already available inside the communication module. So you don't necessarily need two MCUs, one inside the module and another one outside the module. In fact, the main purpose of offering with our modules an application development environment is precisely to allow customers, and this is what CalAmp is doing, to get rid of the MCU they used to put in their electronic board next to the communication module, thus saving money and real estate with one less component, and leverage the processing power and the memory that is available for their own application from the communication module itself. So the MCU, the module, becomes actually the MCU of the full solution. And Todd, please feel free to chime in if something more you want to say about it.
Yeah, that's excellent perspective, Marco. The only addition that I have is that certainly as we look at our own constraints, and that's size constraints and need for performance, specifying the MCU right within the module is something that's front and center for almost all of our advanced applications.
Great, thank you guys. Next question I have here, and Todd, this one looks like it's going to be for you. What prompted CalAmp to develop the Edge Core system and Edge app hosted applications? Was this more of an operating efficiency goal or a goal of increasing capabilities, or both, perhaps?
Yeah, it's a great question, and it's actually both. I think we did this not only to take advantage of recent advances in device processing power so we could do more of the data intake and processing at the edge at the device level and then hand off that post-process data to the platform. That helps us in terms of platform usage and platform usage costs and related maintenance and capacity needs. But also, this more extensive device processing and reporting allows us to tailor what we've built to specific client needs. So the devices can actually handle more than one hosted app at once. You could have a client come in that has a third-party app that they want to run on the device, let's say for electronic logging of driver data, and then they have their own device processing needs, and they would work with us to develop their own app, and those could run together at the device level. So as we see more and more of an integration of third-party solutions, whether it's tracking solutions or sensor solutions, this need to have more edge device processing power is really important to us. So Edge app and the operating system itself, proprietary to us, are really the path forward to do that. It also helps reposition CalAmp as not just a device company. Certainly we want to have core competencies in the full stack, the full solution, the full ability to not only pull in the data from the device, but manage it and then send it out in any way that a client might need, again, through API feeds, blending with third-party data so that we can develop our own custom APIs with our own data and client data, or so that the client can intake it and blend with their own data. And then, of course, our end application, which is getting more and more sophisticated from a tracking and reporting and analytics standpoint.
Great, thanks, Todd. Let's see, next question I have. Marco, I think this one's for you. Can you please clarify how your device management solution integrates with other cloud systems?
Sure. Yeah, I briefly mentioned our device management solution. I didn't go into the details of it, so I understand it may not be easy to get the full picture. But so first of all, let me make it clear that at Telit Cinterion we have no ambition to compete with hyperscalers, the AWS or Microsoft of this world. So our edge to cloud solution wants instead to help customers to efficiently manage their devices and optionally also transport their data in the most efficient way through the cellular network. And this is using an IoT-tailored protocol like lightweight M2M, as opposed to traditional internet protocols that are quite heavyweight, such as MQTT or HTTP. But then, once we have taken care of the data transport over the cellular network in the most lightweight way possible, then the data is routed to the target cloud of our customers. And most of them, in most cases, they already have a cloud system in place. And this is done with standard cloud-to-cloud APIs. So as simple as that. So the flow is the data may go through our platform, and you can see our platform as a proxy, and then we just push all the data to the customer cloud, whatever that is, using cloud-to-cloud connectors. So standard APIs.
Great, thanks, Marco. Looks like maybe another question for you on connectivity. What is best for a global telematics deployment between multi-IMSI SIM and an eSIM?
Yep. So we are talking about the cellular connectivity solution here. There is no straightforward answer to this question, as both the two solutions of mentioned in the question, so multi-IMSI and eSIM, are good to solve specific challenges. So multi-IMSI does a great job in providing global coverage with reasonable tariffs. It increases the connectivity options across different regions, giving on one hand commercial advantages in certain countries, and on the other hand improving the coverage. eSIM, embedded SIM, also known as EUICC, mainly solves the problem of permanent roaming restrictions, giving the ability to download a native local profile when the device wakes up in a permanent roaming restricted country, where roaming profiles are not allowed. The nice thing about Telit Cinterion connectivity offering is that our SIM cards combine into a single SIM a multi-IMSI profile with EUICC technology, hitting two birds with one stone and giving customers the maximum flexibility really for their global deployment. So in a way, the answer to the question is that if you decide to choose Telit Cinterion connectivity solutions, you actually don't have to choose upfront between multi-IMSI and eSIM technology, but you can get both as part of the same offering, and just use one or the other, really depending on what you need when you roll out devices in the field.
Thanks, Marco. Next question I have, how does CalAmp go about selecting a provider for its device modules? What are the decision criteria?
Oh, that's a good one. Thanks, Amanda. Yeah, on that, everyone always thinks that cost is the predominant thing here, but we just talked about this gateway device that we're building. It is a pretty premier device out there, designed and built by us, and very careful selection process there to make sure that the right module provider is there. Certainly, it's reliability in terms of supply chain and making sure that the module is available and will be available. There's also a future-proof component that we want. We want to make sure that the module will have a long life so that we can have a longer overall device life too, given that the module's the primary component there. Certainly support for integration and testing, and overall vendor reliability. And then separately, just do we like working with that partner? And CalAmp has a very long history of working with Telit. Telit's always been very cost effective and has always provided great components and offered really good support to our engineering teams, and has made time to meet with our product teams too, not only to discuss current offerings, but to go over the roadmap of new modules that are on the way. So always being informed of what's going on in the future is certainly important for us, and it plays into our considerations.
Great, thanks, Todd. You mentioned future proofing. So Marco, this is a nice segue into this next question here. You talked about an LTE Cat 1 module. What is the longevity expected for this product and for this technology? And further to that, what happens when either the module goes end of life or the technology itself reaches its sunset?
Okay, good question. As longevity is something that most of our customers do care about. Sometimes they are worried about it, and as Todd mentioned, is one of the selection criteria when somebody like CalAmp needs to pick a module to integrate in their solution. Let's say I understand that every one of us keeps hearing a lot about 5G, now starting to hear even about 6G already. So this may really generate some worry about what's going to happen with LTE. Shall I consider already the latest and greatest technology rather than starting on something that is already out there since a while? So reality is that even with these new generations of cellular technologies coming in, 5G and 6G in the future, 4G, which is another name for LTE, will not go away for quite a long time. There is no single mobile network operator in the world that has already announced any plans for LTE shutdown. And based on our understanding of the market and of the technology evolution, we anticipate that LTE will be supported until 2030, 2035, so for another 10 years or so, in regions like North America, where usually traditionally operators have been moving from one technology generation to the next one quite quickly. If we look at the old world, so to say, Europe, LTE lifespan will be even longer, going until 2040 and even beyond. So we are talking about quite a long lifespan for LTE. That being said, at some point, starting from some countries, we may face the challenge of LTE sunset, or even another challenge of the real world is the end of life maybe of one of the components used in the module. This is something we are very much familiar with, and that we are used to manage together with our customers, following a process that wants really to minimize the impact on their business. We usually give customers a certain period of time to place their last orders. Then we guarantee deliveries for an additional period of time. And meanwhile, we work with them to offer smooth evolution paths to new technologies and products. And this is exactly what we have done with CalAmp, transitioning them from an old part to the current one that they are using for their latest generation devices. And also when the time will come, we will work with them to upgrade their solutions to 5G, offering compatible modules with the one they are using today, supporting 5G technology. So it's an ongoing process, and it's important, as Todd said, to be sure the partner you are working with is managing all these transitions in the most organized and smooth as possible way. So yeah, I appreciate also Todd mentioned this as one of the selection criteria together with the rest. I mean, I think this is part of the the value we want to give to our customers when we work with them, not only as a component supplier, but as a partner and also as a trusted advisor when we talk about technology generations and evolution. And also it's part of the total cost of ownership at the end of the day, because if you select a module just because it's the cheapest one, but then you don't get any support in terms of long-term supply, long-term maintenance, this is gonna at the end of the day screw up the total cost of ownership of your IoT project when you look at the whole life cycle. Yep. So long answer for a short question. Sorry about that.
Yeah, but it does make sense. And that last part about support also ties to when you have something like an edge core operating system, there can be some integration nuances and there can be some module capabilities that just need to be discussed and reviewed at a more detailed level just to make sure that everything works well with the operating system. Anytime a new component is introduced, there are usually firmware updates that are required to make sure everything works seamlessly. So that support is really important there, especially when you have firmware resources here on the CalAmp side that are allocated across a lot of different projects. Having the right level of support allows us to complete the integration and move on to the next project.
Yeah, absolutely. And this is about, again, having the right remote management tools. So it's not only about rolling out a fleet of devices in the field, but it's about having really the ability to make sure you can monitor, maintain, and upgrade possibly those devices during the life cycle. The smarter the devices become. I'm not talking only about the modules, but also about the end device, the CalAmp device, with all the edge intelligence that comes with it. The more you need to have the possibility to upgrade all the software that is inside these devices. It's again it's like it's becoming like a smartphone. We are doing updates on our smartphones from time to time. We're not doing the updates on IoT devices at the same pace, but also the life cycle is longer. So if you have a device that stays in the field for many years, you want to take into account that at some point you will need or you will want to do a firmware over the upgrade.
Guys, great discussion here. I think this is probably a good stopping point for us. I believe that's all the time we've got for today. Audience, please be sure to check your inboxes in the coming days for that replay link. Again, take some time to check out the resources here from both Telit Cinterion and CalAmp. Big thanks to CalAmp for your support today. Marco, Todd, thank you so much for a great presentation and discussion here. And thank you everybody who joined us. Have a good one.